Okay, Alexei, should we get started? Hey, everyone, welcome to Cast AI's webinar for May 15th. We're calling this Zero Touch LLM Deployments at Scale. I'm really excited about this. We have a packed agenda for you today. I want to introduce my co-hosts with me, Yona Apateri. Marianne Gallick's going to be doing the demo. Yona's our product manager for a suite of products that we call AI Enabler. And my name is Leon. I'm a co-founder and CTO. I'm not the CPO. This was a slide mistake of Cast AI. So welcome, guys. Let's start in. We have a really big agenda for you. So what are we going to talk about today? And I want to kind of focus this as a story. The general topic today is going to be hosted versus SaaS managed LLMs. When do you want to use SaaS? When is it appropriate to host your large language models? What kind of infrastructure do you need to do that? We're going to give you a live demo of a very exciting product innovation that we have. And most importantly, as we work through this webinar, all of our foundational product ideas are based on a series of conversations we've had with customers around their pain and their need. And so we're going to dive into those details as we've surveyed those customers and as we've gathered the data. And then finally, we're going to end off with a Q&A. The best question is going to get a very cool award. We're going to leave that until the very end. So we're going to just banter back and forth to figure out who had the most in-depth and detailed question. Let's see how this works out. It's the first time we're trying it. So with that, I'd like to hand it off to Yona. Yona, do you want to talk to us a little bit about the data that we've gathered and how we kind of started the premise for today's presentation?
Sure, of course. So we set out to understand the main challenges of teams building with Gen AI, right? This is a new space. We really wanted to understand what their struggles are and how we can incorporate this feedback into a proper solution that will really solve their problems. So we surveyed 50 teams that are building with LLMs, and then we correlated those results with about 20 customer interviews so that we get a good high-level overview of what the problems are in the space.
Awesome. So let's dive into it, Yona. Why don't we head over to the next slide and start the journey.
Perfect. Talking about journey then, we would like to ask the audience where they are in their AI journey. Let's start off by understanding if you're just experimenting or maybe running a POC, or you're already running AI projects in production.
Okay, and while we're waiting everyone to kind of hit their survey button, this shouldn't take very long. I'm going to answer my question as well here. Oh, hosts and panelists cannot participate. So this is important for us because as we walk you through the content and the demo today, you're going to have different needs and requirements depending on where you are. And we'd really love to know for this audience who the specific target is, and that part of the journey is going to kind of inform our content a little. So this is pretty exciting. I think everyone has submitted the journey. Yeah, so I think we've got
Perfect.
our results.
Interesting. So it looks like the majority of people are experimenting or already running AI projects in production.
That's pretty cool. I didn't expect that last result. So we've got some seasoned and experienced folks on the call today.
That's interesting.
Why don't we hit the next slide then?
Perfect. Okay. So I think those of you that are already running AI projects in production are familiar with this. But let's talk through it. This is the ideal Gen AI project life cycle. Typically, teams start by identifying what they actually want to build, right? That's the scope definition. This is where they look at data sources and they identify the ones that they need. And they do data processing here. Next, they need to select a model, right? So here is where you typically run model evaluations and experiment with different models to select the best model for the specific task at hand. Once that is done and you have your model, then you will want to adapt and align that, right, to your specific needs and to the behavior that you want, which means you're going to experiment with prompt engineering, you're going to do fine tuning, um, responsible AI techniques and strategies are super important here. So you're going to apply safety breaks and content moderation and so on. And now that all that work is done, you're ready for production. And this is where, depending, you're going to select a deployment strategy. Either you go with SaaS inference endpoints or you're going to host it yourself. Model registries, model marketplaces come into play, observability stacks, and so on.
So, this all sounds amazing, but it's a big project. And I know for myself, when I just want to get to a proof of value or a proof of concept, I don't do most of this. And I bet you if we talk to the folks that are on this call and the customers that we've talked to, they don't do half of this stuff. So what's really happening when customers go through this kind of faster version of this journey, if you will?
Let's look into how reality actually looks like then. So, time to market is super important for Gen AI teams. You want to quickly build an MVP, ship it to production, iterate fast, and validate it, right? Validate your idea. So there's a lot of corner cutting that is happening. And you start with just gathering the minimum data for experimentation, and you quickly move on to select your model. And here is where we see teams gravitating towards SaaS inference endpoints, and choosing the most convenient, the most popular model. Typically, what we see is OpenAI is a clear choice, and just choosing the most expensive model, getting started with that. Because evaluating and experimenting with open source models can be cumbersome, as we're going to talk to about it in a bit, right? But let's say you built your MVP, and you release it to the public. Now organizations have a set of new challenges on their hands. The first one would be, because they chose the most expensive model, now they end up overpaying and using a complex, a large model when they actually don't need it, right? Because research shows that a smaller model can be just as effective as a larger model, especially on low complexity tasks. So why would you want to overpay? Um, Second key point here is they're lacking visibility over their usage and spending, especially when teams are handling multiple models from multiple providers. It's hard to aggregate that data and get a high level overview of what's actually happening. You apply that to multiple use cases and teams, and this problem just grows exponentially. And last but not least, personal identifiable information ends up shared with third-party providers just because of the inherent way that SaaS inference endpoints work. So then you're exposed to data privacy leaks and risks and compliance, of course.
So, but all of those problems sound really hard to solve, and I may not have the infrastructure skill on my team to do any of those. But I just want to get started with SaaS. Wouldn't you agree that look, just get me an open AI key, and I don't care about the cost of the model at the very beginning, and let's go. I think that's the fastest way to approach a prototyping problem. No?
Definitely. And that's what data shows us, right? That's what our customers are saying. Getting started with AI is super simple when you use an assess inference endpoints. And the reason is because, first of all, you don't need specialized knowledge to handle the complexity of deploying your own models, right? that's a hard problem to crack. Um, the AI space is new. There's tools that appear overnight. Every day I come to work and there's new tools in the space, and new ways to deal with models and infrastructure. And it hasn't been on the market long enough so that you have experienced people that know how to deal with this, right? So it makes sense then that you will start with something that doesn't require that extra knowledge, right?
So that's great. Let's say I get my prototype done. I'm super excited. I want to get it to market. Now, if I just go to production with an OpenAI API key, what are some of the downsides? Like we touched them a little bit before, but I really want to drill into this. Like, what am I in for? What problems am I going to face?
So once you start putting some pressure and you start seeing some traffic on your application through this integration, you're going to start hitting rate limitations. And this is a major problem that people that we talk to complain about. We've seen teams having to build their own logic, their own routing code to go around this rate limitations. And I think the reason is that there is not enough GPU to go around for everybody, right? So SaaS providers need to set these limitations either on API requests or on token generation and so on. And you can see how it can lead to bottlenecks in your application.
Yeah, there's nothing worse than launching an app only to find that the prompt is down because Azure is rate limiting you or OpenAI is rate limiting you. And it's the worst possible end user experience. So for the teams that are consuming these models, it's got to be very frustrating.
Most definitely is. And then when you factor in cost, right? As we said, low traffic usually means low cost with SaaS inference endpoints. But when you start scaling up, then the cost increases exponentially.
Yeah, that we've heard a lot from our customers. Uh, Pet projects that start off really cheap
Mhm.
sometimes will never make it to production or will come to production with a huge bill of sale that becomes an organizational nightmare. But you want to talk to me a little bit about data because let's say I'm building a risk assessment app or I'm building something in the insurance sector or maybe I'm doing something in medical. Do I really want my customers' data going to OpenAI, sensitive records and information? Or, for example, if I'm working with source code, am I going to risk shipping my intellectual property from my own environment to a SaaS provider? This sounds a little bit dangerous.
Yes, and it is 66. So you can see that more than half of the teams that we surveyed are concerned about this data privacy risk, right? Every time data leaves your local network, you become exposed.
This sounds like a showstopper, right? And in fact, a big portion of our customer base is building a set of applications for exactly these types of data.
Mhm.
And I think this is what really drove some of our implementation details around ring fencing the data that customers can control and make sure that never leaves their environment.
That is definitely true. So then let's have a look at what teams can actually do to mitigate this risk, right?
This is the holy grail, right? This is what we're trying to get to in this conversation. Awesome.
Exactly. So hosting an LLM locally, right, where you have control over the data. So this is a big advantage. It's a big benefit. Of course, it comes with its downsides, but you cannot negate the benefit of having the full control in your hands. And data privacy, when we talk about LLM usage, is, like we said, is very important. And I want to pause here and maybe talk a bit about DeepSeek.
Yes.
Um,
I want to ask you this question because people are deathly scared of the word DeepSeek R1. People are frightened that their data is going to China. Talk to me a little bit about the differences between using DeepSeek in a SaaS version and the way that you can use it kind of with an open weights model that runs in your infrastructure.
Sure. So when you're using a SaaS inference endpoint, your data, all the prompts, your embeddings, everything, it goes to another server, right? Um, so the way, so you can think of a model as a collection of parameters, right? Billions of parameters that the model learns during training. We call this parameter weights. An open weight model is like a public library, right? Where you can go and you can access you can see exactly how the model thinks. And people can scrutinize it and they can see if it contains any backdoors, or even your own teams, right, can do that. So when you deploy such a model in your own network, you can cut it off completely from the internet. So even if it would have a backdoor, which again, it's something that you can check and other smart people are checking, um, you cut it off from the internet and data remains securely in your own cluster, in your network.
Absolutely. So it's safe to run DeepSeek. And to be very
Hmm.
specific, the model weights are it's just an array of it's just a it's just a huge map of numbers, of floating point numbers. And those floating point numbers themselves cannot have a backdoor. They cannot call out to the internet. You need to give the model tools to do that. And that is what an open source model simply doesn't have by itself. Like you have to enable it to do things outside of reasoning. So we're thinking about data sovereignty and privacy.
Hmm.
Obviously, the customization and the predictable costs are really important. So maybe we can move to the next slide. When is it appropriate to run a self-hosted model? When does it make sense?
So we start with data sensitive use cases, right? We talked about finance, healthcare, medical records, situations like this where you really want to keep the data. It's private data, especially when it's customer data. You want to keep it private. You want to keep it in your network. Then when we look at cost, that the cost factor, when we see a high volume token generation, such as chatbots, reg, code generation also generates a lot of tokens, right? Cost increases exponentially, so this is when you want to take control over it. And last but not least, it's when teams need to have control of the model weights. Like we said, the model weights are more like the model's personality, right? And in some situations, you will want to train that and you will want to adapt the model in a certain way. Think about DeepSeek again, right? It's been there. It has some model weights, it has its own personality, but you can change it. When you deploy it, you can change that and you can adapt it to your own needs.
Awesome. And just one point on the high volume. As you start getting into agentic workflows where the model has to iterate over hypotheses
Mhm.
and do things over, that's when token usage explodes. And we're going to talk about the token economics in a later slide. But self-hosted really becomes important as you get to larger contexts and the number of iterations over a problem becomes long. So should we talk a little bit about the well, how does everyone deploy? Like, we should ask the question. Let's go to the next slide.
Yeah, let's do it.
So, folks, how do you deploy your models? Are you using SaaS endpoints today? Are you self-hosting any models? Are you using a hybrid approach depending on the model you want to access? This is going to help us kind of show you. I have a guess, Yona. I don't know. Do you have a guess as to what everyone's using? All right. So
Yeah,
let
I have a guess.
Oh, you're not supposed to tell everyone. It's supposed to be an internal secret, but you can hit the poll number.
We'll take it. We'll take it.
Yeah, we'll take it for sure. Okay. Thanks everyone for filling that in. So what is the data telling us actually? Oh, wow. So 71% of folks are using SaaS endpoints, which makes sense because depending on where you are on your journey. And we have about 30% using either self-hosted or hybrid approach. It's interesting. The economics here are going to be fascinating as we get into into the actual demo here. So what is the data telling us when we talk to our customers?
So data tells us that infrastructure complexity is one of the biggest challenge that customers, teams that are hosting or experimenting with hosting their own models are struggling with. And it's not a surprise, right? Like let's say you start out with using SaaS endpoints, and then you start getting a lot of usage, or you start getting pushback on data privacy related issues. So you start experimenting with self-hosting, but now you have a lot of questions and you have a lot of decisions that you need to make, such as how am I going to provision the resources that I need? Can we run the model on CPU or do I really need to run it on GPU? And when it's GPU, then what's the best region that will give me the availability, the best availability, right?
Awesome. This is great information. I want to just give everyone let's go to the next slide, Yona. I want to give everyone like a 2-minute discussion on GPU economics, some critical mistakes I think folks are making, and where we have an opinionated version of what we think that folks should do. And then I want to get everyone to the demo because I know lots of folks are probably waiting for the live magic. But first, let's talk a little bit about availability. So when you look at the type of GPUs that you can use for model inference, now we're specifically talking about inference, but training is also another use case that you could be thinking about. Think about the availability in Azure, GCP, and AWS. If you want guaranteed availability of GPUs, the cloud provider is going to force you into a long-term commitment, usually 3 years. And we see customers doing this all of the time. And you can see varying degrees of availabilities for A100s, D100s, H100s, and even H200s. They're all gobbled up because they're pretty new. The trouble with reserving an H100, let's say, over a 3-year period is you're paying for that today. By the time you get to the end of your 3 years, you're essentially paying for Amazon's or Google's or Azure's depreciation. And we don't want you to do that. We want to find a better way to get just-in-time pricing that's far lower than what's the on-demand equivalent in the cloud. So we have a tool. Could you just go to the next slide? And we
Sure.
invite you, and we thank you, Yona, and we invite you guys to visit this URL. The spot availability map has a special GPU column or tab that you can go and you can literally see where the GPUs are available, their prices. So for example, when we took this screenshot in Frankfurt, an H100 was $56 on demand when you can get it, but there was spot availability for $14. That's a massive difference in cost considering this is an hourly price. So what if we're only bound in Frankfurt, for example, and there's no more GPU capacity? Well, you're kind of out of luck there, right? You don't have, in a traditional Kubernetes environment, you don't have a mechanism for going outside of Frankfurt. Maybe I want to go to France. Maybe I want to go to somewhere else in the European Union. You can't do that with any type of technology that's available today, at least not easily. So I want you guys to visit that spot availability map. Heed the warning on 3-year reservations because that's literally going to be working against whatever the new version of Moore's Law is. But now we're going to show you how to do this in reality. How do we get those cheap spot GPUs reliably and in any region that you're comfortable with? So with that, let's go to the live demo. And Marian, would you like to take over and show the folks what we've got?
Sure. Okay, so I will share you the screen with the live demo. And Let's start. Iona, I think you should stop sharing the screen because I'm not able to share if you are sharing.
Okay, one sec. Let me see how I can stop.
Okay, so for the purpose of this demonstration, we have prepared a demo application that I'm going to show you. What you can see in this diagram is the current setup in which the application is right now running. It's fairly simple, as you can see. The demo application is running in my own Kubernetes cluster, and it's using OpenAI. So basically, SaaS managed a large language model. And so right now, the application is not interacting with Cast AI in any way. So if I would show you the application, this is basically the application. It says localhost in the URL, but it's running in the Kubernetes cluster. I have just port forwarded the application to my local machine, so it's more convenient for me to showcase it. But this is basically the pod of the application in my cluster. This is the port forwarding. So what does this application? What this application does? Basically, it downloads finance-related news articles from the internet. And then it uses a large language model to analyze the sentiment of the article. So if I press this classify articles button, I will, as you can see in this diagram, we are starting to see some sentiment scores. If I scroll down a little bit, we can see that the application is using GPT-4o model. And this column says OpenAI unregistered. What this means? This means basically that it's using a provider that Cast AI is not aware of. So in order to change this and connect this application to Cast AI, I have to do two things that I'm going to show you. So we are going to change the setup a little bit. And what we want to achieve is what you can see in this diagram. So basically, we need to make sure that the Cast AI is aware of which provider to use. Therefore, we will set up the API key for the OpenAI in Cast AI. And then we will do a small change into our application. So the traffic will be routed through proxy that we have built. So let's just do the sync. So in order to achieve this, I will go to the AI enabler in Cast AI, click register provider. I have several options to choose, but I will choose the same provider that the application is using right now. So I will select OpenAI and give it some name. And then I have to add the API key that the application is right now using. So I will quickly copy paste that here. Yeah, so, and the only two changes that I need to do on the end of the application is that I have to change the URL to which the application is sending the traffic. So usually it's something that's hard-coded or in some configuration or environment variable and so on. But for the sake of simplicity, so it's easier for me to change during the demo, we put it in the configuration in the application, so I can change it in the UI directly. So this is the URL, and I also have to change the API key because the application will be communicating with Cast AI. So I will quickly generate a new API key that I will copy paste and replace the API key that I have in the application. So right now, Cast AI is listening for incoming requests. If I go back to the application and press this classify articles toggle, what we should see is that the application should still work. And as we can see, it does because there are new sentiment scores that are appearing. And if I scroll down, we see the exact same GPT-4o model, but now it says OpenAI registered. If I go back to Cast AI, we will see this report. This is basically a report that is saying something about our usage of the large language models. We can see how many requests we have made, how many tokens have we processed on the input, on the output, and so on. And we can also see some potential cost savings. Up to this point, Cast AI wasn't doing any changes to the actual model that the application is requesting, but we can quite easily change that. If I press this enable router button, what will happen? We will basically allow Cast AI to do some changes to the actual model. So we no longer can see the potential savings. We can see the achieved savings, which are right now 0 because we haven't made any requests yet. But if I will go back to the application and switch the toggle once again, the application will start doing another request, and we will get the request might get routed to a different model. Of course, right now, since I have registered only the OpenAI provider, Cast AI doesn't know about any other providers that are not registered. But since I have selected all the GPT models, Cast AI can choose any from any of these models that I have selected here in the UI. So if I will go back into the application and switch the toggle, then we should start seeing new classifications with a different model. And as you can see right now, it's using the GPT-4o mini for the latest sentiment analysis. So I will switch this off. And if I head back into the cost report, oh yeah, I wanted to leave this. If I head back into the cost report, we can see that now it says those are the achieved savings that has been made by routing to the 4o mini model. So up to this point, the application was using only the SaaS public models. What I'm going to show you right now is how easily you can deploy a model on your own Kubernetes cluster. So which changes needs to take place in this setup that you can see in order to do that? Well, basically what we are going to achieve is the following. We will deploy the model in the cluster. Since the model will be running in the cluster, our publicly hosted proxy that we have been routing the request to, it can't access the model that's running in the cluster. So we are going to deploy the proxy in the cluster as well. And yeah, the proxy can still access also the public models if it's necessary. For example, if the model is down for some reason, that's an optional fallback. And yeah, there will be also some communication to the SaaS part of Cast AI in order to, so we would be able to still show you the report, but the main part of the traffic will stay basically in your cluster. So this is the simple setup that people can do, but we have also developed something a little bit more complex, since yeah, like I could deploy the model in my current region of the cluster, but that wouldn't be very cost efficient, as we will see in a minute. So the actual setup will look something like this. So basically, the cluster has some native region in which are the majority of the nodes of the cluster. But what Cast AI will do, it will create a new node in totally different region. It will basically extend the cluster, so the cluster can communicate with the node in the other region, and the large language model will be deployed on that new virtual node that we will create. So let's do that.
While you're setting that up, I just want to ask you. So what you're telling me is, if there isn't a GPU available in Frankfurt, let's say where we're running the cluster, I can access the GPU in some adjacent region if it's cheaper?
Yeah, exactly.
That's amazing. So I can literally pick and choose the regions that I'm comfortable with as edges, and then Cast will just do the magic of finding the lowest cost capability of GPU for me. And let me ask you a couple of questions. Will the network be secure here? Like, will I have issues? Like, am I going over the public network? Like, what's happening under the covers?
No, well, actually, what's happening under the cover, we are creating private networks in in the cloud. So basically, like there will be no communication that will go outside of the private VPC
So
of the
amazing.
cluster
So
end.
the connection is fully secure. Okay, sorry, I just wanted to confirm that. Please go ahead.
Yeah. Okay. Well, so what I have done, I have clicked a model that I want to deploy for the purpose of the demonstration. I have selected the Llama 3.1 8 billion parameters model, and what Cast AI is telling me right now is that, okay, well, there are no available GPUs that would be suitable to run the model cost efficiently. What does that mean? Well, if I would use the region that is the native region of my cluster, which is the Europe North one, I would be paying $8.5 per hour for the GPU. However, there is an availability in the Europe West 4 region where the GPU that's suitable to run the model costs just 19 cents per hour. So yeah, I can just press the deploy button, and right now what's happening are basically two things. Cast AI is creating a new virtual node in that region and connecting it to the cluster. Once that's done, it will deploy the Llama 3.1 model on that node. So, but there is one more thing that I need to change in order for this to work with my demo application, because as you can see on this diagram, we are still using the public proxy, and we need to use the proxy that has been deployed to the cluster. So in order to do that, I have to copy paste once again this URL. This is basically the local URL on the cluster, and I have to change it in the application. So I will change this to the base URL and hit save. And yeah, right now we are creating for the node to be created and connected to the cluster. Once that's up and running, the model will be deployed and we can try the application. But in order to save some time, because like this can take a while, this can take basically a few minutes. In order to save some time, I have already did the exact same thing before this demo call on a second cluster. So I'm gonna just switch to that cluster. It's the exact same setup. It was just set up a little bit earlier. So let me quickly switch to cluster. So I will cancel the port forwarding to my application, and I will switch to the second cluster. And rerun the port forwarding back. Okay, and let's take a look at the actual cluster. So if I take a look what's running in the cluster, there is still the demo application that's running. But here in the Cast AI agent namespace, we can see the AI optimizer proxy. That's basically the component that's routing the traffic. And in the Cast AI LLMs namespace, we should be able to see the Llama 3.1 model. If I go back into the application and press classify articles button and scroll down a little bit, I should start seeing that the application is right now using the Llama 3.1 8 billion parameters model managed by Cast AI. And so the application basically still works. And if I go to the model deployment to that particular cluster, we can see that the model is up and running. How does the cluster look like? Well, if I go to the cluster list and click on node list, we can see that there are 3 nodes that are the native nodes that are running in Europe North 1 region, but there is this new node called Omni Llama 3.1 that's actually in Europe West 4 region. So yeah, right now we have the application that's using a model deployed in a different region in the Kubernetes cluster. And one last thing that I can show you if we would go to the workloads, we can see also the workload that's running in the cluster. This is the model. And one thing that we'll be working on is basically you will be able to see also the GPU utilization of that particular model and metrics related to that in Cast AI. So that's it for the live demo.
So, man, you're telling me we got a GPU in an adjacent region that's totally secure. The data never leaves your environment. It's a fraction of the cost of what we would have paid for in a local region. And we seamlessly transition between SaaS and local deployed model without any
Yes.
infrastructure knowledge. Like there was no DevOps toil here, forcing someone to understand GPUs, how to scale GPU nodes, how to slice GPU nodes. Everything was taken care of for us. We could use infrastructure as code to deploy this, but essentially it's a highly abstracted set of problems that we've taken care of in this application.
Yes, exactly.
Awesome. Do we want to switch back to Yona just to wrap it up? And I'm just careful looking at the clock here.
Yeah, let's do it. Thank you, Marian. That was great.
Thank you, Marian. That was an awesome demo. So what do we have? Let's get to our Q&A section. So
Finally.
folks, let's feel free to ask questions in chat. I don't know if we can do it live or whatever, if we can unmute people if they want to talk. But we're going to pick the top 3 questions, and we're going to give away tickets to AI Dev Summit, which is happening in San Francisco, or you can join virtually if you don't want to go to San Francisco. So it's a $150 ticket, really cool event, AI Summit. And let's start off with the questions and the Q&A.
See some questions already appearing. So should we start by answering
Let's
them?
go ahead. Yeah, let's go ahead.
Perfect. Okay, so I see Arslan is asking, can we use Cast AI on-prem with OpenShift only to use its routing and proxy features to select and deploy LLMs on local GPU nodes?
Yes, so that's the idea. You'll be able to deploy AI enabler toolkit it doesn't matter, it's Kubernetes version agnostic. What you don't get out of that configuration is essentially the up and down scaling. But if you have static GPU nodes, you can absolutely use them as part of the process.
Wonderful. Let's move on then. How would you design and implement a robust CI/CD pipeline, incorporate continuous training workflows, and ensure scalable, reliable deployment of a production-grade LLM system? Big question.
Okay, so the idea here is, so training workflows are a little bit outside of the scope of this presentation, but if we're talking about the deployment of models, our whole goal here is to create abstract CI/CD concepts like custom resource definitions as an example. So you can literally just use Argo to deploy these as higher order cluster objects and not worry about the underlying infrastructure that's going to be required to get those provisions. So if you think about an experience like Crossplane, for example, where Crossplane gives you a set of higher order objects, you populate those CRD, those custom resources essentially, and the reconciliation loop will just take care of it and build out the cluster and provide you the endpoints of the object. And we think that that is obviously the whole CI/CD process is a much longer discussion. Maybe it's a good topic for another webinar, but on the inference side of building out the infrastructure you need, which includes scale to zero, upscaling the models, leveraging the best GPUs, fully utilizing the GPUs that you have, that's the process that we envision. There's another great
Awesome.
question from Madavi. Let's go to that. How do custom built models or ensemble models in the process? So custom built models will adhere to like a very specific weight structure. We use VLLM under the covers actually we use two. There's two runtimes we use, Olama and VLLM. If you have weights in any of those, any of that are compatible with any of those runtimes, which most are, then you'll be able to run them in this environment. And the same is true for Hugging Face downloaded models, which answers the previous question.
So basically, if your model is based on a transformer architecture, right, typically it should be fairly easy to support.
And one of the things that we're very anxious to support in AI Enabler in the fullness of time is very streamlined fine-tuning, very similar to the OpenAI experience that you have today, where you provide a list of JSON Q&A, basically questions and answers. You'll be able to fine-tune an open source model, add it to a registry, like an Artifactory, for example, and then use those models just like you would any open source model.
Looks like we have a follow-up question. So do we support rolling update on custom pods?
So the pods themselves are like the manifest for the pod itself is structured by cast. But if you have if we have new versions of the models being rolled, yes, we support rolling updates for those. So let's say you have five replicas of a model running and you wanted to initiate a rolling update, you could absolutely do that. Thank you, Madhavi.
Awesome.
All right.
Thank you.
So I think we're gonna wrap up. Like we've got like 3 very vocal folks, so you guys are getting those tickets to AI Dev Summit. If there are any other questions, please throw it into the chat, and let's just talk a little bit about what you're working on and how we can be helpful to what you're working on. If you guys want to engage, we are at an early stage of development in this very exciting product. If you guys want to engage as design partners for your use cases, we want to hear from you. Grab this barcode on the webinar, fire Yona an email, and we'll get you set up with a calendar invite and we'll walk through your use cases. We're very much looking for the edges, what people are thinking, how they're thinking of designing their pipelines. And we want to be helpful in abstracting that infrastructure. So thanks very much, everyone. Yona, thank you for putting together this presentation. Marian, thank you so much for this amazing no demo god failure demo. And guys, we'll see you guys all very soon. Thanks so much.
Awesome. Thank you.